In today's lecture, we're going to study how to find the sum of first n terms of arithmetic progression. Okay, so this is a further topic of the chapter what we have selected, and in the last lecture I have finished how to find the nth term of arithmetic progression, and we solved few problems on that. In today's lecture we're going to see how to find the sum of first n terms of arithmetic progression. Let's start the class. Here, and to find the sum of first nth term of arithmetic progression, I'm going to consider the positive integer series. And I use one technique, and that technique what I'm going to use to solve that problem, I'll be using the same technique to find the sum of first n terms of arithmetic progression. Okay, now let's consider the positive 1 to 100 positive integer series. Okay, so I'll take S as the denotation for the sum of first n terms. So S is equals to what I have done, I have considered from 1 to 100. So I'm gonna write that, I'm gonna summing up that. Okay, and I consider this as equation 1. Okay, next what I do, I'm gonna take the same form in the reverse order. This is a forward order. Now I'm going to consider this expression in the reverse order. That is nothing but 100 plus 99 plus 98, so on till 1, and I will be considering it as equation 2. Now I'm going to add equation 1 and equation 2. Okay, therefore adding equation 1 and 2, what I'll get? I'll get it as 2s 101, because I have to add 100 plus 1, plus 99 plus 2 is nothing but again 101, plus 98 plus 3, again it is 101, so on 101. Till 100 times I'll get it as 101, 101, 101, 101, because I have taken it as 1 to 100, so I'll be getting 101, 101, 101. Okay, so what I'll do again, I'll write it as 2s is equals to 100 into 101. So finally I'll get s as 5050. Okay, by solving this I'll get s as 5050, nothing but 5050. Okay, now I'm going to use this technique to find the sum of first n terms of arithmetic progression. So what I have done, instead of adding 1 plus 2 plus 3, I didn't do that. What I did, I considered the two equations, one in forward order, one in reverse order. I added them. Okay, I came to another equation, I got it, and that equation I solved it, because I know I have taken 100 integer. I'll be 100 times, I'll be getting this 101 term. Once I get this one, I'll be dividing it by 2, and finally I'll be obtaining S as 5050. Okay, I'll be using this method to obtain the sum of first n terms. Okay, let's do that. Now let's consider general form of arithmetic progression. Okay, I have to consider the general form, which is nothing but a comma a plus d comma a plus 2d comma a plus 3d, so on a plus n minus 1 into d. Okay, now what I do, I have to get the sum of first n terms. So s is equals to, I'm gonna add this series. Okay, a plus d plus a plus 2d, so on till a plus n minus 1 into d. Okay, and I'll consider it as equation 1. Now this is the forward order. So according to the example what I have taken, I have to consider the reverse order also, and that will be my equation 2. So S is equals to A plus n minus 1 into D plus A plus n minus 2 into D plus so on. I'll get it as A, and that will be my equation 2. Okay. Now I'll be adding equation 1 and 2. Okay, I'll be adding equation 1 and 2. From that, I'll get it as 2s, which is equals to 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus so on. I'll get it as 2a plus n minus 1 into d. Okay, this expression I'll get it as at n number of times. Okay, now what I have to find? I have to find only s. So therefore, and these terms are repeated n number of times. So directly I can take it as n into, and this 2 will come here. Okay, and what I'll get? I'll get it as 2a plus n minus 1 into d. Now this is equation. It is well and fine, good. It looks like, okay, I got the expression, but still it is a lengthier. Let's reduce the equation size. Okay, what I do, I'm gonna split this term. Okay, what I'll get, I'll write it here. S is equals to n by 2 a plus a plus n minus 1 into d. Okay, this term is nothing but an, correct? So in the last lecture we studied about how to find the an, and this term is nothing but the an. This is our nth term, which is also our last term L. Okay, therefore I'm gonna denote this term as L. Okay, therefore we can write S is equals to n by 2 a plus L. Okay, now this is the formula to find the sum of first n terms of arithmetic progression, where L is nothing but our last term, which is nothing but an, and an is nothing but a plus n minus 1 into d. Okay, I'll repeat once again. Now what we are doing here, we are finding sum of first n terms of arithmetic progression. For that I need to consider the general form of the arithmetic progression. Then I have to add the series. When I am writing in the forward order, I will be considering it as equation 1. When I write it in the reverse order, I will be considering it as equation 2. Okay. Now I am going to add these two equations, and I will get this big equation, in which 2a plus n minus 1 into d will be repeating n number of times. So this whatever repeating n number of times, I will reduce it into n into 2a plus n minus 1 into d, and whatever 2 is here, it will come here. It will divide the fraction. Okay, it will come into the denominator. Now I have to simplify this. So since I have some possibilities of getting a simpler form, so therefore what I'll do, I'm going to split this 2a into a plus a. Okay, once I split it into a plus a, this 1a plus n minus 1 into d will give us an nth term, which is also our last term L. So I'm going to denote this as, instead of an, I'll be denoting it as L. Okay, because I will be assuming it as a last term. Then finally I obtained a simplified form of sum of first n terms of arithmetic progression. I hope you guys have understood this. We'll solve few problems on this. Okay. Okay, I'll write the formula here. Sn, I'll denote it as Sn, n by 2, A plus L. Okay, now we're gonna solve few problems. Okay, let's consider the first problem is for given AP, find sum of first 10 terms. Okay, what I have to do? I have to find the sum of first 10 terms, and the given series is 2, 7, 12, so on. Okay, I have to find the sum of 10 terms. So, since I have to find the sum of 10 terms, what are the data I want from the given series? First, I have to check whether it is an arithmetic progression or not. Then, I have to find n, I have to find a, I have to find l. Okay, now first I have to find whether the given series is arithmetic progression or not. For that, we will do the consecutive difference. 7 minus 2 is nothing but 5. 12 minus 7 is nothing but 5. So both are same, both are constant. Therefore, given series is AP, from which we get, implement that we get the common difference D as 5. We got the common difference from the series. I can find out that A is nothing but 2. Okay, and in the question they have mentioned first 10 terms, therefore n is nothing but 10. Okay, now I'm going to substitute this one in the given formula, but I need L, correct? Therefore, how to find the L? L is nothing but last term, which is nothing but an, which is nothing but a plus n minus 1 into b, which is equals to 2 plus 10 minus 1 into 5, okay, which is equals to 2 plus 45, which is equals to 47. Okay, now what I have to find? I have to find Sn. Therefore, Sn is equals to, which is equals to S10. S10 is equals to, n is how much? N is again 10 by 2 into A is 2 plus what I have got L. L is nothing but 47. I'll write the 47, which is equals to 5 into 49, which is equals to 245. Okay, this is the answer for sum of first 10 terms. Okay, I'll explain once again. They have given us the series and they have told us to find the first 10 terms of the arithmetic progression. First, find whether the given series is arithmetic progression or not. Once you find, simultaneously you will get the D. Once you get the D, then find the rest factors. I need A is given, and N they have mentioned in the question. Once you get this, compare with the formula whether you have all the data. You have to find L. L is nothing but our last term, and last term formula is this one. Substitute that one, and you're going to get the Sn. Okay, so this is one type of problem. We'll see the next problem. I hope you guys understood this. We'll see the next one. So, given that A is equals to 5, B is equals to 3, An is equals to 50. Okay. Now, what I have to find? I have to find N. Write the complete question. Find N and Sn. Okay. This is another category of the program in which they're gonna give you A, D, A, N, or they might give you N. So and they'll tell you to find N and Sn. Okay. Now first to find Sn, I have to find first N. So let's first find the N. Then we're gonna find the Sn. Okay. First we have to find the N. Correct. To find N, what data I have? To find N, I have An. So an, what is the formula of an? An is nothing but a plus n minus 1 into d. So here I have n and I can find the n here. Okay. Now what is an? They have given 50 and 5 they have already mentioned the question, which is 5 plus n minus 1 into d. D is 3. Okay. Now 15 minus 5, which is equals to n minus 1 into 3. Okay. 45, this 3 comes this side, 3 which is equals to n minus 1. Okay. So n minus 1 is equals to 15, n is equals to 16. Okay. Therefore we got n as 16. Okay. We found the n. Now we have to find Sn. Okay. Sn is equals to n by 2 a plus l. Okay. What is l? L is nothing but an, and we have found n, which is nothing but 16. Okay. S 16 is equals to 16 by 2. A is 5 plus 50. Okay. S16 is equals to 8 into 55. Okay. And you'll get the answer as you'll get the answer as 440. So this is the another category of the problem where they'll give you the data of A, D and AN. You have to find N and Sn. Okay. And you once you solve the problem, you'll get the solution as 440. I hope you guys understood this. In the next problem, we're going to move to the next category wherein we're going to find a formula, we're going to find a simple form for a positive integers, okay, using sum of first n terms, okay. So we'll see that. Okay. Find sum of first 1000 positive integer. Okay. I have to find this one and I have to use for this one this method. Okay. What is S? S is nothing but 1 plus 2 plus 3 plus so on till 1000. Okay, this is the first 1000 positive integers. First I have to mention it in a series so that I can find N, A and L. Okay, so what is A? First A is 1. What is N? N is nothing but 1000. They have mentioned in the question. In the last term, L is also nothing but 1000. Okay, I got all the data whichever I have required. Now what I'll do? I'll directly find S1000, which is equals to N is how much? 1000. 1000 divided by 2 into what is A? A is 1. Again, last term is also 1000. Okay. So, how much I'll get the answer? 500 into 1001, which is nothing but 5 lakhs 500. Okay, so it's a very huge number, right? Now for which one we have found? In this one we have found for the 1000 integers. Okay, for 1000 positive integers by considering the series, and we find the required data for the expression what we have. Then we substituted everything and we got the answer. Now let's say they have given you 65. They have told you to find the first find the sum of first 65,000 positive integers, which is very huge number, right? Again you have to find all those stuff. Instead of that, there is another simple method. So okay, I'll consider for that as n term. Okay, so instead of here 1000, I'll give it as n. Okay, what we have to do? Find the sum of first n positive integers. Okay, for that S is equals to, first represent the series. Okay. Now, what is A? A is 1, N is N, L is N, last term is L. Now, if I substitute in the formula, Sn is equals to, N will be N by 2, A will be 1, and the last term again will be N. Therefore, Sn is equals to N by 2 into N plus 1. Now, this is the simpler form or simpler formula what we have to find the sum of first n positive integer. Okay, if they told you find the sum of first 10,000 positive integers, directly substitute in this formula and get it. Don't go to solve in any other methods. Okay, directly you can get through this one. Now let's consider, I'll consider it for 500. So they have given n as 500 to me. Okay, if I like what they have framed the question is that find the sum of first 500 positive integers. So n is nothing but 500. S500 is equals to 500 divided by 2 into 500 plus 1. Okay, S500 is nothing but 250 into 501. I'll get the answer as 125 250. Okay, this is the answer for if they given n as 500. Okay, so this is to find the sum of first n positive integers, a simpler method what we obtained from the first n terms of arithmetic progression. Okay, so there are plenty varieties of series what you get. In that you can do like finding the problems, all those stuff, or finding the answers, in which you should be able to do the simpler formula so that you can do it easily. Okay, so this is what we got. Okay, I hope you guys understood this. There are a lot of varieties of problems on sum of first in terms of arithmetic progression. So I have done till I have solved 3 to 4 problems, and I have found a new formula on that also. So I hope you guys have understood this, and this is the last lecture for arithmetic progression. According to the syllabus, I have covered almost all the topics whichever were there in the prescribed syllabus. And if you have any doubts, or if you have any problems or which need to be solved, or you want some more, you have some more doubts or something, you can put your doubts, whatever is there, put it in the comment section. Thank you for watching.